Here are some practice problems for you to go ahead and do. So if you want to go ahead and pause the video, work through these and see if you got them correctly. And then I'll have some answers on the next couple of slides. So the first question was 7 square roots of 3 minus 2 square roots of 3. So again, let's look underneath the square root sign. Are they the same? Yes, they are. And so we can go ahead and this time it's subtraction, but can we go ahead and subtract 5 and 2? Yeah, we can. We can go ahead and do that. So our answer is 5 square roots of 3. The second practice problems, we have the square root of 8. Remember, we want to go, is this simplified as much as possible? No, it's not. And we want to use numbers that kind of come from the perfect squares list. So we're going to simplify the square root of 8. We're going to simplify it down to the square root of 4 times the square root of 2. And can we simplify that even further? Can we take the square root of 4 and get a whole number? Yes, we can. That number is 2. Can we take the square root of 2 and simplify that any further and get a whole number? We cannot. So that one's going to stay as 2 square roots of 2. We are still adding everything together, okay? And then let's look at the 3 square roots of 2. Is this simplified as much as possible? Well, it is. So it just kind of stays the same until I can come down to here and go, oh, I have 2 square roots of 2 plus 3 square roots of 2. There's a 2 underneath the square root sign here. There's a 2 underneath the square root sign here. I can add those front numbers together and get 5 square roots of 2. Moving on, we have 2 square roots of 2 plus 7 square roots of 18. Again, we need to go ahead and look at it. Can I simplify this number? Is this simplified as much as possible? Yeah, it is. So I'm just going to leave that number there. Okay, and we know that we're adding. So I'm going to kind of leave that number there. And let's just kind of focus on this 7 square roots of 18. So remember the 7, it stays out on the front. Okay, we don't do anything with it. But then we're going to go ahead and we're going to reduce down the 18. So again, we want factors that kind of come from the perfect squares list. Well, look, there's a 9. So I can take 18 and I can do it as square root of 2 times the square root of 9. Now let's go ahead and let's look at them. 7 stays the same. Okay, can I take the square root of 2 and get a whole number? Well, is it here or here? Can I take the square root of 2 and get a whole number? No, so we're going to keep that there. Let's look at the 9. Can I take the square root of 9 and get a whole number? Well, square root of 9 equals 3. So if we look at it now, we now have 7 square roots of 2 times 3. And again, mathematicians, we love it where we're going to take the 7 and the 3 and we're going to put it out on the front. So see how we have 7 times 3. And then we still have the square root of 2 sitting there. And then we are going to go ahead and do 7 times 3. Well, hey, what is 7 times 3? That is 21. And again, as you notice, the square root of 2 stays there. So now we have reduced down this number to 21 square roots of 2. We're going to look at the square roots. Okay, so it's the square root of 2. Here is a square root of 2. Is this square root of 2 the same as this square root of 2? Yes, so we can go ahead and add those front numbers. So we're going to say 2 plus 21. Well, what is 2 plus 21? That is 23. And then we still have that square root at the end. So our final answer is 23 square roots of 2. Last couple of questions. Let's go ahead and look at them. So we have 3 square roots of 20 minus 3 square roots of 2. So let's look at 20. Can I reduce down 20 any further? I can. This is not simplified all the way down. So remember also that the 3 stays at the front. Nothing happens with him. And then we're going to look at the 20. And we want to do numbers that come from the perfect squares list as far as the factors. So I'm going to go ahead and factor 20 down to being square root of 4 and then the square root of 5. And then we want to simplify it even further. So the 3, again, the 3 kind of stays out there. And then we're going to go ahead and we're going to look at square root of 4. Can I take the square root of 4 and get a whole number? Well, the square root of 4 is 2. And I'm going to keep that there. And then can we take the square root of 5 and get a whole number? Well, is it on this list? Is 5 in there at all? Well, it is not. And so we're going to have to look at it, and we're going to keep it as the square root of 5. We're still subtracting everything. And then can we simplify this any further? So we're going to take 3 times 2, and we're going to go ahead and get 6, and then the square root of 5 stays the same, and we are still subtracting. 3 squares of 2. So square root of 2, is it simplified? It is. So this number actually stays the same. We're just going to kind of bring it down. And now we're going to look at both of these. We have 6 square root of 5 minus 3 square root of 2. Can I add a 5, a square root of 5, and a square root of 2 together? Are they exactly the same? They are not. So this is a funny answer, but the funny answer is 6 square root of 5 minus 3 square root of 2. This would be the final answer. It would be simplified as much as it can. The last question that we're going to go ahead and look at is 5 square roots of 3 plus 3 square roots of 12. So let's look at the 3. Can we simplify this any further? Well, is there a square root of 3 on this square roots list? There is not. So it's actually going to stay the same. And I kind of brought it down just to kind of help, and we're still adding. And then let's go ahead and let's look at 12. Well, the 3 and the 12. So remember, the 3 is going to go ahead and stay there. Kind of bring it out there, it stays there. Now the 12. The 12, we want to go ahead and factor it into something smaller, and we want to have numbers that are from the perfect squares list. So I went ahead and I did it as square root of 4 times the square root of 3. And then let's look at it. So the 3 on the outside stays there. Let's look at the square root of 4. Can I take the square root of 4? Well, the square root of 4 is 2. So we take that. And then square root of 3, can I do the square root of 3 and get anything? No, as you can kind of see, it's there. And so it's going to be now reduced down to being 3 times 2 and then square root of 3, because we cannot take the square root of 3. It is not part of the square roots list. It is not one of the answers on the perfect squares list. We want to simplify this further, so we're going to say 3 times 2. Well, what is 3 times 2? That is 6. And then notice how the square root of 3, this square root of 3 kind of came down and sat there because we can't do anything further with it. Now let's look at, can I add these together? I have a square root of 3 here. I have a square root of 3 in the second one. They are both the same, so the number underneath the square root sign is the same. So then I can say 5 plus 6, and then combine those together. So what is 5 plus 6? Well, that is 11. And then we have it as square root of 3. So this is how to add and subtract radical numbers, or numbers underneath the square root sign. And we need to go ahead and make sure that we simplify underneath the square root sign first before we can go ahead and add those, and then add or subtract them, and then we can make them smaller. Hopefully you learned something today, and if you need to go back and review this again, you can. Please make this useful for yourself. Thanks. Have a good day.